Hi, my name is Rob. This is a build video for this little guy. So you will see that it's a 7-inch drone, but this is only a 290mm frame. So it is substantially more compact than most 7-inch frames, 2 or 3 times smaller even in some cases. You'll also notice that it looks like a cyborg robot from the 1950s. So this drone was completely made on CNC with the exception of the motor mounts, which are just super common 12mm. Okay, a couple things first before we get into it. Just a little history. I've spent about maybe 3 years now designing drones by hand. Before that I was into road vehicles, and before that I was into helicopters. So I probably like building these things more than I like flying them. I'm certainly not the best pilot out there, but I do try to come up with some very unique builds. So I spent 3 years building drones by hand, using templates and cutting things out by hand. Then last fall I got a CNC. After rebuilding the whole entire CNC because I wasn't happy with it, from the beginning of this year, I would say I got out of working with helicopters because it was like 80 to 20 fixing to flying ratio. And don't get me wrong, I actually love the building and the designing more than the flying, but it was getting too much, and there's no such thing as that was a close landing on a helicopter. If you don't land it, it's broken. Something's broken for sure. So I started got out of flying altogether, got into land vehicles. I've got a couple of pretty crazy trucks, twin engine Nitro Savage, with about 8.5 horsepower, and an Arma Outcast running on 12S. So both of those are insane. So anyway, I decided to get back into drones. Came up with a number of very interesting designs. Got the CNC. Then I decided that I think it's about time that I start logging some of this stuff. So let's just go over what we have here. So top and bottom plate, 3mm. We have a DJI O3 air unit, and I spent a lot of time and iterations of this design coming up with something that would be fitting for the O3 air unit. And by that I mean you can take the propellers off of this, arm it, and set it down somewhere, and 20 minutes later it hasn't thermally shut down. There's a fan on the top, and if you look inside at the O3 air unit, you'll see that there is a orange heatsink in there. So you've got a fan blowing down on the orange heatsink, and then the bottom of the O3 air unit is thermally coupled to this aluminum plate. So you don't have to worry that you're exploring, you're just looking around, you're not flying. There isn't 300 km/h of wind going past the O3 air unit to stop it from shutting down. And this thing will keep on recording and keep on sending signals. So we have a 40 amp 4-in-1 ESC. I think it's a HAKRC. Kakude H7 flight controller running iNav 6.11. We have a micro GPS unit, and of course the diversity antennas. I actually spent quite a bit of time working with how to mount these antennas. And so you'll see now worked out really well. So we're going to do a series of build videos on this. Oh, I didn't do the electrical specs yet. Okay, let's go over the electrical specs on this. Okay, so we are going to switch over to the PC now. Okay, here we are at the computer. So these are just real super simplified settings. So we have the base weight without the battery, 497 grams, and the total thrust, 3.75 kg. So these are the estimated values. We have 3 different batteries here, a ProTech 4300, Redline 6000, and a Redline 7500, all high voltage. I know it doesn't make that much difference, but we're trying to squeeze every bit that we can out of this. You got the all-up weights for each of the 3. And then this stuff is pretty approximated. Obviously, depending on how aggressive you're flying. But the interesting thing, though, is if you look at the flight time between the 2 batteries, you don't see any difference really between the 6 and the 7500. But once you get down to the 4300, then you're starting to take time off of the flight time. But the thrust to weight ratios are all really good. I mean, anything I think over 3 is fine. I mean, if you're going to do racing, then obviously you're going to want something more, probably even more than 4.5. But for exploring, it's perfectly fine. So the approximate flight distances are better with the higher battery though, but depending on what you're planning on doing. So this is all super basic stuff. I haven't actually verified all of these values with flights, so that's about it. The original version of this was done by hand last summer before I got the CNC. The whole object of it was flight time and range. I didn't care how strong it was, how robust it was, or anything like that. It was still kind of nasty out. It was not really flying weather. I had everything set up so nice too. And I thought, I'm just going to give it a little brief run in the house. What could go wrong, right? So anyway, I think that the stick wasn't what I was expecting on the transmitter, and I just went to press the arm to shut it off, and on the way I accidentally floored it. So this is what started this whole thing with the CNC. It hit the ceiling. It was completely destroyed. I had 3D printed motor mounts on it at that time. The arms were broken from where the motor mounts were connected on. It wasn't strong enough. The entire electronics were, at the time I had a Vista that was inside of the dome being cooled by a fan on top of the Vista. It was actually working really well too. You could feel the heat being blown out the little side vents. But it was way not robust enough. Like, it could not handle any kind of a bad landing whatsoever without some kind of damage. So I did sacrifice a lot of flight time and stuff. And this one is a lot more robust. So we're gonna do a few videos. I'm gonna recreate this again. So we'll go over, I'm not sure how many videos it'll be at this point, but I'll take you over the 3D stuff on Fusion 360, and I'll show you what I have for all of the parts that are involved in making this thing. There's actually quite a few. And then we will actually make it. And I have a special treat for the next version, which is I got some MEP engines that will be same hover flight time, and I think roughly the same flight distance, but 200 kilometers an hour, so it'll be a little more lively. I would consider those to be pretty hot. We'll get all that done, and I'll show you all of the steps that are involved in making it, and then that will be it. So anyway, thanks for hanging out with me. Hopefully you think this thing is as cool as I do. And we will start another entire new one altogether on the next video. So if you've ever had a dream of flying, let's make it a reality. Until then, good to be with you.